Okay, hi, I'm Amanda Olson, and this is Maths 2410 at MCC or Calculus 1. If you're in my hybrid class, I've taken this problem from section 3.3 or from the review practice problem number 9. So this problem is using the first derivative test. Now, if you're in my calculus class or a different calculus class, a lot of times, you may already be aware that there is a second derivative test. However, given the context of this problem and the directions, I'm going to proceed using the first derivative test only, and I'm not going to use the second derivative test. Depending on where you are, you might have access to the second derivative test, and you'll be able to use that. All right, so first of all, for this problem, we want to find the critical numbers for our given function f. In order to find critical numbers, that is going to be values within f. And so I look at where f is undefined. F does not have 0 in its domain. 0 is not in the domain of f. And the reason for that is because that's where the derivative of the function equals 0. And so since 0 is not in the domain of f, 0 is not eligible to be a critical number or a critical value. That's an important distinction because we have to have that the critical number is in the original function. All right, from there we want to find critical numbers, and those are values of f, values of x where f equals 0. So I need to have, or where f prime equals 0, so I need to have f prime of x. So for me, I'm going to find f prime by using a mnemonic device of the quotient rule. It uses the hi-ho. You may find the derivative using a variation of the product rule, bringing that x squared up top. You may just use the quotient rule as it's defined. Whichever way you use to find the derivative of f, go ahead and do that. Like I said, I'm going to use a mnemonic device of hi-ho for the quotient rule. So it's not the quotient rule, but it's a mnemonic device that helps me to remember the quotient rule that I teach in my class. So I have ho d high minus hi d ho all together over ho ho. So simplifying, we have x squared minus 2x squared minus 8x over x to the 4th. This simplifies to be a negative x squared minus 8x all over x to the 4th. Okay, and there's a variation of ways that you can simplify this from here. A lot of times people get stuck with the quotient rule because their algebra simplifying rational expressions isn't very strong. So if you struggle with, maybe you get that quotient rule, you have that first step, but after that, you don't follow my work, or you get stuck on a problem, but you're able to get that first quotient rule, or maybe, it's a quotient rule problem and it just gives you f prime and you're like, how did they get f prime? A lot of times that's an indicator that the algebra skills are missing something. And so for you, you might want to pause the video and say, okay, let's look up simplifying rational expressions. And you can Google that, or you can email me and I can give you more resources. But if you're like, I struggle with simplifying those rational expressions, I struggle with getting the derivative that they find. I feel like I got the quotient rule down, but finding that derivative, I'm not understanding. I would say, pause the video and look up, kind of practice some simplifying rational expressions, because those are going to continue to be an issue. From here, our derivative is negative x squared minus 8x, and we want to know where is that undefined or equal to 0. Well, the only place where it's undefined is where the derivative equals 0, and that happens at x equals 0. F prime is not defined when x equals 0, which a lot of times would mean if the derivative doesn't exist at 0, then 0 is a critical number. However, for our specific function, 0 is not eligible to be a critical number because the original function wasn't defined there. So we don't consider x equals 0 a critical number, but we do consider it when we're looking at our tables for increasing and decreasing because it's where the function's not defined. So from there, negative x squared minus 8x over x to the fourth equals 0. If and only if x squared minus 8x equals 0, factoring out a negative x, we get x plus 8 equals 0. The zero factor theorem says that this is going to equal 0 if and only if x equals 0 or negative x equals 0. However, x equaling 0, we've already said, it's just not one that we're considering. So then we have otherwise x plus 8 equals 0 or x equals negative 8. And so negative 8 is eligible to be a critical number, and it is in fact a critical number. So from there, we want to set up a table to find increasing and decreasing. So I'm going to pick a test value in my interval. From there, I'm going to be concerned with my sign of f prime. Now you could go ahead and find f prime explicitly given your test value. I like to just consider, well, what's the sign? Because sometimes all that arithmetic number crunching isn't necessary. And you can save yourself a lot of time by just saying, okay, what's actually the sign of f prime? Yeah, I know it's going to be like a negative, really large number, but I'm not really concerned with what is its actual value. The intervals that we're considering, we have negative infinity to our left critical number, which is negative 8. From there, our next interval is going to go from negative 8 to 0. Even though 0 is not a critical number, it's not in our domain, so we can't talk about it increasing or decreasing over 0. So we put it there as a placeholder, even though it's not a critical number. From there, we have from 0 to positive infinity, and we consider what is our graph doing there. So negative infinity to negative 8, I get negative 9. For negative 9, I see that I'm going to have a f prime that is equal to negative 81 minus a negative 72, which will give me a positive 72. So my sign is going to be negative, and my conclusion is that it's decreasing since f prime is negative for that interval. From negative 8 to 0, I'm going to choose negative 1. For negative 1, we have a negative 1 plus 8. X to the fourth is positive across the real, so we don't even consider that denominator for the sign. So I have negative 1 plus 8. This is going to give me a positive, so I'm going to see that it's increasing in that interval. And then from 0 to infinity, I'm going to use a test value of 1. For 1, we're going to have a very negative f prime. So it's going to be decreasing from 0 to infinity. All right, the last step is to find a relative extrema using the first derivative test. So if you think about your graph, this is the way that I remember the first derivative test. Your graph is decreasing, right? It decreases and decreases and decreases until it hits some low, and then it switches to increasing. So you're going to hit an all-time low or a valley, and that's going to yield a relative min. And that's going to occur when x equals negative 8. From there, you're going to be increasing, increasing, increasing until you get to 0. And then you're going to switch to decreasing. So you might say, well, there should be a relative max at x equals 0. However, because it's where the denominator of the function equals 0 and the function is not defined at 0, what we know from previous math classes from algebra is that at x equals 0, you're going to have a vertical asymptote. And so we can probably expect that it's going to increase without bounds. And you have that vertical asymptote of x equals 0. From there, our graph switches to decreasing, and it's going to decrease without bounds. So for that reason, we have no relative max, and we only have a relative min. And so our relative min has an x value of -8, and then we go ahead and plug in -8 into our original function. We find f of -8 to actually find what is the value of that relative min. So that's going to be a -4 over a positive 64 or a -1/16. And then we have no relative maximum existing. Thank you.